Here we have a function. We're asked to find the equations of the asymptotes of the graph of this function. So first of all, let's put our graph into our calculator. I'm going to delete the one that's already in there, and I'm going to put in the fraction button, x squared minus 3 over x squared plus 5x plus 6. With that drawn in there, I'm going to hit enter to draw it, and I get this weird looking, almost like a heartbeat shape in the middle. Now remember, this is because my view window is not set particularly well, and the calculator is getting a little bit confused with such a wide range of values. So I'm going to change my view window to the standard ones, from -10 to 10 on both the x and y values. And then I can see a little bit better what's going on, though still not great. I've got a little bit here, but there seems to be this gap here. So let me zoom out a little bit on the y-axis. Maybe if I go from -20 to 20. Oh, and then I see this bit up here at the bottom, but it's connected and it shouldn't be connected like that. Again, that's because my axes are a bit wide. I'm going to try and go for something like let's go from -5 to 5 on the x-axis, and keep it at -20 to 20 for now on the y-axis. Ah, there we go. That's a little bit better. Maybe now I can just scroll across. I possibly don't need to go quite as high up there, so maybe bring that down to, let's say, 15. And I'm starting to get a bit of a picture of what this graph looks like. Now, I need to find the asymptotes. So the asymptotes, first of all, I'm going to look at the vertical asymptotes. Vertical asymptotes look like they're coming through maybe here and here. That one looks more likely to be 1, so -2. So we're going to do a g-solve, y-calc at -2, and we get an error. So that means that x equals -2 is indeed one of the vertical asymptotes, because there is no value at -2. The other one looks like it's somewhere between -3 and -4. So let's just give it a try, a y-calc at, let's say, -4 first. No, it's finding a solution there. Let's try at -3. And it's not finding a value there. So -3 then is our second vertical asymptote. X equals -3. For the horizontal asymptote, it certainly looks like it's approaching 0 on this side, maybe on that side. To do that, let's think about what's happening at large values of x. So I'm going to go out to 50, which is fairly large. And for my y values, because I think it's around 0, I'm going to limit them between -1 and 1. And when I draw that, oh, actually it's not. It's not approaching 0 here, because it's up there. Okay, that's interesting. It looks like it's approaching 1. So let's change our view window again. Instead of going from -1 to 1, I'm going to go from 0 to 2, so that 1's nicely in the middle. Ah, there we go. Now we can see it seems to be approaching 1 as we go off to the left and to the right. If I wanted to confirm that a bit wider, I could go for different x values, make that a bit wider. And yeah, it definitely looks like that it's approaching 1 as x gets bigger and bigger, both to positive infinity and to negative infinity. So my horizontal asymptote, which I can find graphically, is y equals 1. That is why you have to really zoom in on those y-axes for these horizontal asymptotes, because when we were zoomed out, it looked like it was approaching 0 when we were going from -20 to 20. It looked like the horizontal asymptote here was going to be at 0, but it wasn't. We had to zoom in to be able to see that actually it was going to be at 1, not at 0. So you always need to do that zooming in thing if you're checking for horizontal asymptote graphically.